Hi, my name is Shivangi,
And I'm Stephanie Liu.
and we are computer science and engineering students. Today, we'll be introducing ORIENT, a mobile application that uses augmented reality to teach object-oriented programming.
In our technologically advanced society, it is critical for students to develop an understanding of computer science fundamentals. One important computer science concept that students often struggle to understand is object-oriented programming, or OOP, which is key to many programming languages like Java, C++, and Python. Object-oriented programming helps programmers write more flexible, concise, and reusable code. However, a significant instructional challenge is that OOP is more abstract than structured programming. Therefore, a visual and hands-on approach can be used to teach these programming principles.
Augmented reality has also proven to be an effective tool in educational settings. It facilitates learning because it enables exploration and visualization in 3D space. And studies have shown that it boosts content understanding, intrinsic motivation, retention, and performance. So, the goal of our project is to use augmented reality to help students understand abstract concepts in OOP.
Our solution, ORIENT, is a mobile application that uses augmented reality to teach object-oriented programming. Unlike existing solutions, our platform provides a guided learning environment with clear learning outcomes. While playing around with objects and interacting with the tutorial exercises, students are introduced to actual code syntax and structure. ORIENT is designed for novice programmers from the middle school level up, and it consists of a 3-part tutorial series that teaches class creation, inheritance, and polymorphism, 3 of the most important tenets of object-oriented programming. Students can learn at their own pace and easily navigate between and within tutorials to supplement their own knowledge as needed.
To build our application, we used Unity AR as our game development environment, ARKit as our iOS development platform, and C# as the programming language for scripting and creating functionality for the app tutorial and exercises. In addition, we established 3 main objectives to assess our application's performance. Our first objective was to present educational content in an age-appropriate manner. Second, we wanted to build an intuitive AR experience where students wouldn't be too bogged down with learning vocab or code syntax. And our final objective is to encourage students to explore OOP in a guided, encouraging environment that prioritizes learning over gamification.
Each of ORIENT's 3 tutorials focuses on a different OOP concept. Through explanations and interactive exercises, users write code to create AR car objects in their own environment. The first tutorial covers the basics of class creation. The objective is to create a class car and instantiate a car object. The goal for our second tutorial is to enable users to identify inherited and or derived versus unique attributes and behaviors of a subclass. And finally, our third tutorial focuses on using polymorphism to change the implementation of an inherited method. For performance evaluation, we tested ORIENT on 6 individuals ranging from middle school to college. Our test subjects were primarily novice programmers, and 2 were middle school students. These 2 figures are derived from our feedback forms, and they show how our testers rated their familiarity with object-oriented programming before and after using ORIENT. Prior to our testing, we had 3 users who were very unfamiliar with OOP and 3 that were somewhat familiar. After using our app, all testers rated the familiarity as 8 out of 10 or above, indicating that ORIENT was very effective in teaching OOP concepts.
So going back to the objectives we mentioned earlier, for app evaluation, we wanted to take our users' inputs and see if they aligned with our goals. Our first objective was to provide educational content in an age-appropriate manner, and here's what our student testers affirmed. They liked how the application didn't stress too much code verbatim and focused on user engagement. They liked that important words were bolded. They liked the different colors that made it helpful and easy to follow. The UI essentially was very self-explanatory and easy to use. Our second objective was to build an intuitive AR experience that would use AR to enhance learning rather than distract from it. Our student testers said that the AR and live demonstrations of the code really helped with understanding the material, and that being able to visualize what they were coding made it easier to see each line of code having an impact on the visualization. They also said that the tutorials were short and sweet, concise, but also thorough. Our last objective was to encourage students to explore OOP. After testing our app, they really liked the visuals and how interactive it was. It made it easier to learn and understand the concepts. Specifically, polymorphism with the make sound function was great in demonstrating a typically hard concept. Our last student mentioned it would have been great for introducing them to programming and definitely would have helped them learn the basics better.
From our user testing, we also got feedback on potential areas for improvement. This slide highlights a few features from our existing implementation that could be improved. First, several students mentioned that they had some difficulty with the code writing exercises because they had to type code exactly as shown, including case and space sensitivity. Secondly, some of our instructions could have been worded more clearly. And finally, there are minor changes that would make the app experience more pleasant. Things like adding smoother transitions for the blue place or removing the blue placement indicator from the background of scenes where it isn't needed. Most of these issues could be resolved fairly easily with some additional code revisions.
And that brings us to the end of our presentation. We're hopeful that this project can shine more light on how immersive technology can be used to enhance education, particularly in the field of computer science. Thank you all for listening to our presentation today.